Now we're going to solve quadratic equations using the quadratic formula. This is the third way that I've got algebraically to solve quadratic equations. So first thing we have to do, make sure your quadratic equation is in standard form, descending order. I usually have my students indicate what A is, the value of A, the value of B, and the value of C. And then, here's your formula. You should know this. I always get my students to go find the discriminant because the discriminant gives you a lot of information. The discriminant is just the number under the radical. It does not include the radical, just the b squared minus 4ac. Now if you find your discriminant, if it's positive, then I'm going to have two solutions. But now depending on what number I have, if I have a perfect square, I have two rational. And all rational means, base word here is ratio. I can write the answer as a fraction and I get an exact value for it. Now if it's not a perfect square, then I've got two irrational, which means not rational solutions. There's no way I can write a fraction, write the value into a fraction that will give me that exact answer back once I apply the radical. Okay? Now if my discriminant is 0, I have one rational solution because 0 is a perfect square. If my discriminant is negative, I have no real solutions. It is an imaginary number, but we're just going to say no real solution in this class. Alright, let me keep on going. I've got some examples, and you should have seen the quadratic formula, and you should know the quadratic formula. Now this, I don't know what you did in the past with respect to the discriminant, but you need to know what happens when you have a positive, a 0, or a negative. So I've got some examples we're going to look at. So first thing I want you to find on these is the value of the discriminant. So all of these are already in standard form, so you've already got that done. So I need you to go find the discriminant and see if you come up with what I did. So pause me and go find it and then come back. You should have enough room, you can find it. So on this one, if you find your discriminant, you should have ended up with 1. In this one, our discriminant should be 0. Discriminant here, hopefully you came up with negative 4. And my discriminant down here, I came up with 17. So I have an example of every one of the situations indicated earlier. 1 is a perfect square. Let me move this up just a little bit. 1 is a perfect square, so I'm going to have two rational solutions. 0, here's 0 right here in the middle. One rational solution. Negative 4 right here. It is an imaginary number, or so imaginary solution. And 17, positive, but it's not a perfect square, so I've got two irrational. I thought I would highlight that. Now my solutions. Here comes the quadratic formula. So what I need you to do is go find your solutions, indicate, using your quadratic formula what they are, and then I want you to see if you come up with what I do. In this one, I came up with x equals negative 2, or x equals negative 3. 0, you should have ended up with x equals a 7. This is when I have that double root. So these two, actually 1 and 2, if you come up with a perfect square, the thing could have been factored to start with. And this one, no real solution. I really like this one. It's very fast, but you won't get any, usually. Now in this one, let's see if you first ended up with, you should have ended up with 11 plus or minus square root of 17 over 4. This is an exact answer. So let's see if I can go and get my approximations. So because this is a binomial, I need parentheses. So I've got 11. I do the plus route, the upper route. square root 17. Now, I had to end the parentheses here with the 17 to tell the calculator that this is under the radical, but I need another parentheses to tell the calculator this is my numerator. So however many left-handed parentheses you have, that's how many right-handed parentheses you need. So let me divide by 4. So there's my 3.7801 if I round to the third decimal place. The only difference between these two problems is that minus. So if you'll do your repeat, let me cursor back in, change that to a negative, hit enter. You do not have to cursor out. Okay? So if I go on down to solve a quadratic equation for exact solutions, that means algebraically. If it's in the form of ax squared equals p, or you have a quantity squared equals p, solve for the square, and remember to take square roots. When it's not in the form of 1, write it in standard form. So if it's not in this form, rewrite it in standard form. Okay? Try to factor. Usually factor is faster if you can notice it, and use the principle of zero products. If it's not possible to factor, or factoring seems really difficult, use the quadratic formula. The solutions of a quadratic equation can always be found using the quadratic formula. But it has to be in this form first. So you've got some problems to do, so get back in touch with the quadratic formula. Talk to you later. Bye-bye.